Roar.
So here's a little silly song. Hello, it's me and Lewis with Brandon Rohrer. We're gonna talk to him and learn about what he's done in his life. Hooray! Hooray!
Yeah.
I can die a happy man now.
That's right. You
we're
got your own
delighted
song.
to have you. Yeah. In
So-
his life, in our lives,
Exactly,
You've been a great influence.
So to start, I was just going to talk about like Brandon Rohrer. I mean, we're just going to talk about you. We're not going to ask you questions yet. I just want to tell everyone. A lot of people ask me like, what are your influences and how did you get to where you were? And a lot of that has to do with Brandon Rohrer. Throughout sort of my whole YouTube experience, he was doing stuff as well, and I was learning from his YouTube stuff and his blog posts and whatnot. But also, this is my favorite thing. Brandon used to be on Twitter back in the day, and you posted something. I don't know what it was, but I do remember commenting back to you something kind of snarky. And as soon as I posted, I kind of regretted it, but I left it anyways. And you wrote back the most thoughtful, courteous response ever. And that to me was like, oh, that's how you behave on the internet. I want to be like you. And ever since then, whenever I do anything, I think I was like, what would Brandon do in this situation? I always do it because you set the tone, and it had a huge, profound effect on me and how I interact with people on the internet from then on, and it's to this day. So anyways, I just wanted to throw it out there.
Wow, amazing.
That's really touching.
Can I be? This is amazing. Yeah.
Yeah.
Can I be next on the
Yes,
circle
please,
of praise?
yeah.
Because I remember Brandon was the first educator like I looked up to, because I remember when I was just starting my channel and I just had a couple of thousand followers and maybe one video or two. And then I think it was in Seattle, but it could have been in the Bay Area that we were at an ODSC. And I was looking at all your videos because it was like I understood neural networks for the first time because of your video that where you had some convolutional stuff. And 90% of my content is about, what I understood of neural networks. And so I wrote to you like a message, but I was just an unknown guy. So I was like, hey, I'm a big fan of your channel, blah, blah, blah. And again, you were so nice corresponding back, like so thoughtful and so you could have been arrogant, but you chose not to be arrogant at all. And it was like, let's meet now. I like your material too. And then we met and I went to your talk, which was wonderful. And then you went to mine. And all I thought to myself was, if this guy's treating me like an equal, I gotta do this. And then I decided to continue with the YouTube thing, and I went home and made a bunch of videos because made me take myself seriously. And so I thank you for that.
Wow.
Wow. And then there's another thing that I actually kind of copied from you. And I do give you credit on the original videos, but I keep doing it. And it's two things. When you do an image, you start with a 2x2 image and you do like a slash or a backward slash, or like an X and an O with a 3x3 image. And you look at, I understood CNNs exactly from there. And to this day, when I do anything with imaging, I do that image like a 2x2, and I work out the whole neural network, like exactly what you did. I did that with later stable diffusion and everything. And another one that I like even more is when you do text. I was always trying to do little phrases like, I don't know, the little house in the prairie, whatever. And you had this video where you explain a recurrent neural network, which in that the first time I understood recurrent neural networks, which you use sentences of the type, John saw Mary, or Bob saw Spot. And Spot is the dog, which is genius because Spot is also a verb. And so Mary Spot, I thought that was the coolest thing in the world. And to this day, I just made 4 videos in LLMs, and I use that sentence structure, like Spot, John saw Mary. So I keep doing that. So I think you pop in I would say 95% of my material is based on ideas and stuff that I understood thanks to you. I don't know if I ever had the chance to tell you this, so I thought I could tell you in public. So thank you so much.
That means so much to me. Especially because I look up to both of you so much. Like, there's a short list of people making really accessible educational ML content out there. And so the fact that you two are just the giants in that area, like what, yeah, that just means a lot that I had any hand in all at all in that. Um, and yeah, thank you. Thank you for that. You just
Hooray,
made my
hooray.
week. I'm taking that.
Oh.
So, hooray.
Thank
So,
you.
so for those of you who are new to Brandon Rohrer and don't know who he is, let me just give you a list of some of the companies. I can't even do all the be exhaustive, but he started out at Sandia National Laboratories, which is kind of amazing in and of itself. He's worked at Microsoft, Facebook, iRobot, LinkedIn, Patreon, and now you're at Patreon, which is helpful for me. And so you've kind of been all over the place. And that I think that leads us to one of our questions for you, which is you started out, I believe, as a mechanical engineer. Is that correct?
That's exactly right.
And
Yeah.
how did you transition into data science, AI, and all this sort of machine learning? How did that happen?
For me, it was all the same journey. As a little kid, um, I, I'm going to date myself. I saw The Empire Strikes Back, Star Wars Episode 5, in the theater when it released. And I was blown away, and among all of the awesomeness there, Luke had a robotic hand. He got it chopped off and he got a new one. I'm like, whoa, that's so cool. And so that kind of captured my imagination. And I'm like, wow, machines are powerful tools. Like, you can do cool things. And so that led to me like so many garage projects, like making a little, like, I used a motor from a blow dryer to wrap like twine to like make a little hinged 2x4 flex like a muscle. And like and I was all about like I had a little dirt bike that I repaired and did tricks on, and later a car that I rebuilt. Just like machines just super fascinated me. And so when I was getting ready to go to college and then grad school, I was like, I want to do robots. Like, robots are the coolest. And so that was mechanical engineering for me. And then I studied it in grad school. I ended up in actually a lab that did robotic prostheses. There weren't very many of those, but there were a
Wow.
couple. And
That's
I
kind
was able to land in one. Yes. And so I worked on an
Oh my
arm. It
God!
wasn't
Like,
just a
let's
hand.
kind
That's so cool.
your
Hands are
childhood
way harder than
dream.
arms. But yeah, working on a prosthetic arm, and it was a
Yeah.
blast. And so but eventually I got my graduate work transitioned to like stroke rehabilitation, which we were doing in that same lab using robots to help people who'd had a stroke make the movements and put effort behind them in order to rewire their brains and recover. And we were able to do amazing things with that, which led to some theories about, wow, how does the brain regenerate movement? Which led to some fun theories because as a robot, humans are horrible hardware. Like, we have these huge, like 150 millisecond time delays from the brain to the muscle and back. And if you tried to design a robot controller to control that, it would be a disaster. The brain does it no problem. So, like, what does the brain do that robots don't do? More importantly, for me, more interestingly, like, how can you take that then and put it into robots? So that just led down this thread of like, well, how do computers control robots now? Like, what are the algorithms? What are the constraints? What happens when hardware gets sloppy? What's the signal processing involved? What's the like physical sensors? How do you like wire it up? How do you make this all work? And it kind of let that hardware and software part of robotics come together. And then I realized that the coolest part of robotics to me was the software,
Huh.
was the brains. And so I kind of leaned into that, started studying more, like developing my own like machine learning algorithms. Like, my very first thing, like, there's this little robot video, a little tracked robot, like a little mini tank about 4 inches long with a little camera on the front. And I'd have it drive around and be powered by a really simple algorithm about when to, like, steer and move. But I had it learn on the fly from its own experience, which is something that is hard to do and rarely done. So I started with a very simple case to do that. And that was kind of like my first video that, back in the day, it did numbers. Like I had 5,000 views, and I was like, whoa, that's
Yeah.
huge. Um, but I started realizing, like, wow, this machine learning stuff, I should know about that. And so I started, reading textbooks, and I had never taken a proper machine learning undergrad or grad
Yeah.
class. And so then I ended up getting a job at as a data scientist in industry, and going to Microsoft, and like, hey, this whole machine learning stuff is really like getting popular now where it used to not be. And there's been a lot of hype around neural networks, especially convolutional neural networks at the time. They were the hotness, like LLMs are today. So it's like, I don't understand these. I hate not understanding things. And so I was like, well, what if I explain it the way that I wish that someone could explain it to me? What if I figure it out and kind of write that explanation? And so I made my first ML video, convolutional neural networks video, for myself to teach me
That's
about
awesome.
convolutional neural networks.
Yeah.
And and it was well received, and that was kind of the pattern. After
Right.
that, I'm like, ooh, I want to understand this other thing. Let me make a video. Let me write a post. Let me write a little tool that does it. And that's how if you go through and look at my blog now, it basically reads as a stuff that Brandon got curious about and felt frustrated that he didn't understand.
We'll get to your blog in just a second, but can we go back to that very first video? It's like a family affair. There's someone playing the violin, little Bach piece. I don't know if you remember that, but in the background, there's a little Bach. I don't know who's playing.
I do.
And you have a narrator, which is definitely not you.
So
Can you tell us about the people that helped you with that video?
I have I have 4 human children. The oldest is a violinist,
Fantastic.
and at that time was, I think they were 7 or
Okay.
8. So perhaps, yeah, so young. But they were the soundtrack. And then the next youngest, I think, was 5, perhaps 5 or 6. And they were the narrator. So I gave them a
It's just
script
about
and
the
asked them
cutest
to record,
thing
which they
on the
did.
internet, and it's basically machine learning in a robot, and it's just so adorable. I just love it. That's amazing.
Wow.
So
Yeah.
I was pretty excited. The bigger reason behind it is I was like, this stuff tends to be buried behind these impenetrable
Yeah.
equations. And I
Yeah.
hate that. Like, it's a lot of the ideas are super accessible. I get a little mad actually when I like take something that was intimidating and then I understand it. I'm like, well, why didn't you just say that?
We have
And so
Yeah.
we have that in common. I feel like
kind of
frustration was my main fuel.
I think all 3 of us. There's
Yeah.
a reason why we do
Yeah,
what we
for some
do.
right, fueled by spite.
But I love how you went.
So I wanted to make it really
I
accessible.
love how you went from the Empire Strikes Back, the hand, and then you studied that. Your degree is in MIT, by the way, your PhD.
Yeah.
Very impressive. And then you went to actually make the hand, and then you went through the brain. You said, okay, the hand is controlled by a brain. Let me understand the brain, and that was the bridge to machine learning, basically.
Yeah. I think so. Like, in retrospect, it looks like a path or a progression in the process, which continues today. It feels more like wandering around in a dark room with a very small light and shining a light over here and shining a light over here and just kind of going where the curiosity goes. And eventually you look back and you're like, oh, well, look at this, look at this journey I did. But there was no way to be able to see even a few years ahead. Like I end up in places that I didn't intend to be.
Sorry.
No, go ahead.
I was gonna. So, I love your blog. It's amazing. Which came first, YouTube or the blog?
YouTube.
Oh, okay.
Yeah. I was. Let's see. YouTube videos were kind of the first thing, and then the blog came shortly after. I'm trying to remember now because they're both like 15 years old. And basically, I started like having thoughts. Like there would be a conversation, or I'd have like a inspiration. This was like pre-Twitter, so I'm like, I've got a thought, I've got to get it out, and so it would turn into a few paragraphs, and it would like then I'd be like, oh, here's the thing. Like, I just want to stick it somewhere. So for a while, it was a GitHub repository. But then I really got serious about wanting to own these things a little more, like make my own little corner of the internet. And so that went from a GitHub page to eventually I, got a domain and did some like a really remedial HTML, and it evolved into what it is now, which is still super bare bones static web page that I like generate all the HTML myself, like minimal tool stack, but it's mine. And I feel pretty proud about that.
And you have this school, all right, like end-to-end machine learning, which, by the way, want to direct our viewers to that. Let me put it in the chat.
So a caveat here, it is pretty much mothballed at this point. But I enjoy teaching. I got a lot of great feedback from teaching. A lot of folks are like, wow, I heard this and I understand it. And every time that was like this bloom of excitement, bloom of pride. I'm like, I want to do this with my life. And so I thought, well, how about if I set up a school, like a place online, you can go, you pay a little money, you get a little content, and like everybody wins. And so I did that and really enjoyed it. And it motivated me to like really put myself in the seat of, okay, someone's learning this. What are the gaps? What are the things where if I go to search it, not very much comes up that's accessible, I can fill that gap. I can put something here. I can do a no steps skipped walkthrough of going from this concept to some Python code to something you can run on your own personal computer. And I love that. I found it so satisfying. And then I thought, well, great career path. I can stop working for, the man and come and like do my own thing. And then I realized that teaching, the most important part of teaching, this is something I learned from you both, is the one-on-one interaction between the teacher and the student. It's not the generating of the content necessarily. That's the starting place. Then it's the follow-up, the answering the questions, the like, I just don't get this. Like, can you explain it another way? And the back and forth. It is by nature, like, it's like a handmade Italian suit. Like, it doesn't mass produce well. And but it's a beautiful thing. Like, there's nothing finer. But it's not an easy road. Like, it's not again, I don't have to tell, I'm not telling you anything you don't know. And I realize that for me personally, as much as I enjoy the one-on-one, I'm still very selfishly driven by curiosity. And it's like, well, I want to go explore the next thing now. Like, I'm done with that. I made it. And it's like, oh, but I've got a question. I'm just discovering this. I'm like, and so if there were two of me, if I had full time to develop, if I just, really just like took the plunge and dove in, I could have made it work, but I made a tough decision and kind of stepped away. So everything that I had up there, I made available for free, but also I stopped paying my, subscription to the platform that I was on. And so now it's kind of spun down, but I'm still pumping content into my blog. So that like would be my school, but just with no contract or understanding of like, big follow-up conversations. It's like, here's some material, do what you want with it.
Well, even in its mothballed state, I get all the time, and we've actually had a few questions as well on this live stream about people wanting to have like roadmaps for how to learn topics. And even in its mothballed state, your end-to-end machine learning has roadmaps, like for whatever topic, convolutional neural networks. You've got like 30 topics that you should know. And so if people want to know what they need to know, I still think it's an excellent resource as a roadmap. They're very comprehensive, and it's all in one place, and it's convenient. And you may have to find the material other places, but at least you're going in the right direction. So I think it's still got a place, and like,
that's awesome.
Yeah,
it's still super useful.
No, I definitely recommend everybody to look at it. And it seems like it seems like maybe for you it looks scattered, but at the end it was your process of learning, and
Mhm.
that makes it very linear and organized, even if it wasn't intended, right?
Yeah.
Like when you put things back, then you put them in a pretty comprehensible way, because you needed all those steps. I mean, there's definitely a trail of steps. So yeah, it's a wonderful resource.
Yeah.
Yeah.
Thanks. I hope that people find it helpful. And I sympathize with folks who are learning, who are like, I don't know this. I want to learn the skills of data
Yeah.
science or the skills of machine learning, because it's not a really well marked path. Like it's a more like a landscape. And at this point, nobody knows it all. And so you kind of get to choose where to go. But if you don't have any signs to guide you, it's hard to know. And I don't have, when people ask me about that, for one, I say, take my advice with a grain of salt because it's old and the world is different now than it was when I was taking these steps. But the other thing is like, choose something that you want to build. Like if you love games, build a game. If you want to build an automated like garage door opener closer, like build that, like home automation or like whatever it is that like you're curious about or interested in, or like if you want to build like a camera trap for bird watching, like, you know, like find a thing to build, even if it's like too big, even if it's ridiculous. Like I want to build a spaceship that'll, can autonomously fly to the moon. Like what would I need to do to start getting in that direction? Um, and That's what's driven everything for me. That's what helps me decide, like, well, what do I need to do
Mm.
next in order to get to
Yeah.
this place?
Seems like your gradient is joy and curiosity.
Yeah.
No shortage
Pretty
of
much,
that.
yeah.
Curiosity mixed with the frustration
Oh,
of not understanding
that,
the
yeah,
thing.
yeah, yeah.
Like,
Do you have any like click moments where something clicked, like a neural network clicked, or AI clicked, or robotics, like in any aha moments that you remember in particular?
uh, I remember there were a couple that during the first convolutional neural network um, video where that was where I realized that all of this stuff was learnable. When I was kind of like pouring through the papers and looking at the various descriptions of what a kernel was, like, what is it?
Yeah.
Popcorn? Like, I don't know what I'm working with here. Um, and also the actual convolution operator, where I'm like, oh my gosh, it's just multiplication and addition. And like as you move this thing across the rows and the columns, I'm like, you're just sweeping. Like there's these fancy words for these simple concepts, and then just having them click, click, click one after the other. And I'm like, you can take this thing that's big and people talk about it as if it's enormous, and you can break it down to its nuts and its bolts and look at them and play with them and put them back together. You can build your own slightly differently if you want, once you understand how it works. And that was just like, okay, this, it's a big world, but it can be my world if I'm willing to do the work to get into it. I remember another one of those when I was looking at oh, I'm spacing on the name now. Machine learning algorithm where you have these little boundaries. There's linear
Support
separation
vector
and there's
machines.
overlap
Oh,
region.
SVMs,
Thank
yeah,
you.
yeah, yeah.
Support vector machines. Yeah. Whereas like support vector machine sounds so
I know.
intense and so scary. And then I started breaking it down. I'm like, oh, and the kernel trick. Oh,
Yeah.
and transformations. And once I started to get all the pieces, I'm like, oh, wow, okay, like I can own
Yeah.
all this. And then a recent one that is now one of my most popular posts is like on transformers. This was like I don't know, 3 or 4 years ago now, where I'm like, okay, I guess this like latest shiny thing is not going to go away anytime soon. I should learn about it. And spent a little while and just broke it down for
Yeah.
myself to like uh, the bare bones, to like be, oh, okay, I see how this
Yeah.
works. And so mad respect for Luis, your recent series of Transformer, like here's how to build like the minimal transformer. Like that level of understanding is just like it's like little fireworks.
Thank you. That's straight from when I saw your first CNN video of like the minimal CNN that will differentiate between a 2x2. I knew that was the way I was gonna understand all of ML. So that's definitely your knowledge propagated there, because that sort of minimal example to me is the way I understand things. Josh also does this, right? Like we have this sort of building the minimal, and seeing things, right? Which comes from building stuff, right? Like you just have to see the parts. I wonder if Lego was ever a thing for you. Like, did you play Lego as a kid? Because I was,
all the time.
I feel like my brain is got wired by playing this, building little things, and you never stop, right? Like you never stop playing with things. I have Legos.
I was the oldest of 6 kids. I see them there. Yeah, I was the oldest of 6 kids, and that was like Legos were a pretty popular toy at our house. But my dad he was an engineer himself. He's like, cool, like for the first time, open the instructions, build the thing, sit it on the shelf for a month, break it all down, it goes in the bin. And then when it's Lego time, you take the whole bin, you empty it out on the floor, and you just build like whatever you want, you build. And so that definitely was formative.
Nice.
I also think something we should do, I was just inspired by what we were doing a little bit ago, but maybe one day we should do like an ML charades.
SVM, yes.
Exactly.
That would be a good one. We'll make
2 words.
I was like,
neural network.
We should definitely do like a game show or something. Points
I would love that. I would love. Plus the names in ML, I feel like the marketing person who came up with the names of algorithm is like support vector machine. That sounds so fancy. So it sounds like Star Wars stuff.
I know, right?
Seriously, Transformer. Like
looking for funding.
Definitely.
Yeah.
Well, some things like deep learning, right? Like it was called neural network, and a story I heard is Jeff Hinton. He was mocked by doing neural networks, and then they changed the name to deep learning as a kind of way to make it sound cool again.
And it worked.
Then it became super cool.
Yeah.
Yeah.
I can see that. It's definitely tangent off of that, but it's definitely worth looking at how the methods are affected by the people involved, the current technical culture, like what tech companies are doing, what it's being used for, what's getting funding from government agencies. Like there's a lot of overlap there. You can zoom like way back into the 50s and 60s, and it was like a lot of symbolic stuff like logic. And it's like, if we could just break the world down into like, if this, then that, and this is a subset of that. And if we could just nail that, then we'd have intelligence solved. And then we got kind of far and then not very far. And then funding agencies got bored. And then it's like, winter, robotics, ML, no funding for a while. And then it comes back, then it goes away. And then it comes back, and then it goes away. And then it's coming back like with wildfire, with LLMs and transformers and the promise that it can solve everything. The cycle has been like, we play it out, we explore, and attention shifts, and it'll still be a thing, but there will be another thing. And it's kind of fun to see how that pattern repeats.
What do you think are things that will come next? Like things that could be the next breakthroughs for?
Ooh.
Could be robotics as well, right? Like I want to pick your brain on that too. But
Yep. I think one thing that's ripe is reinforcement learning. It's an idea that's been around for a long time, and it's been like there's lots of toy problems where reinforcement learning works well, and lots of real examples where it barely works or works poorly. We have a lot of biases in how we the world approach machine learning that make things hard for reinforcement learning. Like it makes maximal use of every single data point. So it's really good for small data, for things that are like very, I don't know, like crafty, very like learning on the fly, things that might take a long time to train. And so that's totally at odds with like, well, why don't we ingest the whole internet and then use like an entire country's worth of computers to train it. And it's like, well, reinforcement learning is not going to work. It's like an inherently serial process. Um, so it'll take a big shift of approach, a big fundamental shift of resources. It'll take probably a few like killer apps, but I think that my instinct is that once we like invest a similar amount of effort into that, it'll be capable of ridiculous things. And yeah, and that's my personal like favorite space to toy with, to play with.
That's a good question.
Yeah, I was going to say
What
that.
was your last, that's how I should have explained it moment?
I have this moment. It's not quite that's how I should have explained it, but it was watching Josh explain linear optimization.
Yeah, right.
And I was like, I've always wondered how that worked. Oh, that's awesome.
Yeah. I'm the same.
Yeah, and so I'm like, but it was one of those things where it never. It always kind of like, again, like, oh, I don't understand that. Never made it to the top of my list, and then it's like, oh, that's brilliant. That's such a good explanation.
Right.
Yeah.
Right. Thank you.
Definitely.
Thank you.
Yeah, you did mention an interesting paradigm, which is we went from logic from trying to figure everything out, right? Like even in an image, trying to figure out how to understand it by if and then, and we giving it our knowledge, to like saying, you know what, do your thing, you learn, which is kind of like if you're teaching a kid everything that you know versus letting him roam in the world and learn stuff. And I feel like when that happened, then that's when machines started really learning, right? Which actually leads to this question, because I was going to ask you more if reinforcement learning, another step of freedom there. Like we have the logic, then we have like the training with data, and then reinforcement learning is like letting it make its own data and learn, right? So where the question is, where does reinforcement learning work best? Will it be relevant? And can you mention some examples? That's a good question.
It is so it's a really simplified model of what animals do, where it's just like you try a thing and you get yummy food, you do that thing more often. You try a thing and it hurts, you do that thing less often. So it's really good in tasks where there's that feedback, that structure is frequent, and it's you have the freedom to explore. Like if it's like, oh, here's a piece of cake, here's a vial of poison, like you drink the poison once, you don't get to come back and do it again and again. So you need some like non-catastrophic learning not to play in traffic. It's like not a good place to do reinforcement learning. And so it is so it's nice to find a problem like that where it's like there's like lots of data, the consequence for getting it wrong is small, and you have the ability to like just keep going on it. And that's the question of where it would work best is actually I think that's one of the reasons why it hasn't taken off yet, because it's like hard to find the right problem where reinforcement learning is the answer for the question. If it's a well-described problem like spam filtering, then you have a whole bunch of data, you train a model, and then you maybe like repeat that process periodically. If it's a really narrow problem where the consequences are intense, then you do have logic. You have some really hard boundaries. So you don't play in traffic and you don't drink that poison. The thing where you're just kind of like free to wander around and try things, it's like the ceiling is so much higher for what you can learn, but the training time is huge. So it takes patience. It's not like efficient. Time efficient. It's very data efficient, but it's not time efficient. So as long as it's driven by, hey, what can we train and sell next half, or what do I want to invest in, then that's like not likely to lead to a lot of reinforcement, at least not obviously to a lot of reinforcement learning applications, unless they happen very quickly. And so I think there's opportunities for that. But for hobby type things where the consequences are low, there's a lot of opportunity to mess around and kind of start to work out the kinks.
So I was just thinking, so one of the things that made Transformers work so well is the ability to do so much in parallel, right? And is there a way to sort of, when we learn, I was just thinking about when you're talking about eating the poison, that's something we sort of, like humans or animals, a little bit do in parallel, because we'll be like, okay, you try this, and we're going to watch and see what happens to you. and if you live, we'll try it too. There's a way of getting like collective knowledge, right? If somebody dies, we all learn from that experience. Everyone in the tribe goes, okay, we learned from that reinforcement learning, we're not going to eat that berry ever again, or we will, and there's there a way to sort of like have like a swarm of things that can parallelize the learning that all of the devices can learn from.
That I think is like really key, because like you called out, like kids, they have a lot of parental help when things work well, avoiding catastrophic outcomes while they learn not to do things. So thankfully, there's a lot of kids who have never tried to stick a fork in a light socket in an outlet.
I did.
But
I did too.
Well, you turned out
it's 2 out of 3.
Make a
I did in the fun in the
It's
like,
not the
I
wrong
did in the
answer.
dumbest way, because I noticed this is I'm gonna date myself too. I remember that when if the TV antenna wasn't working very well, I put a metal knife to it and started working well. That's my first. This is a chain of ideas, not
positive
necessarily
reinforcement. Positive
so
reinforcement.
putting a knife in the antenna, for the younger generations, antenna was where the in top of a TV, and one day we didn't have cable when they started saying TV cable. I was like, oh, that's cool, but only the rich kids had it. They didn't have TV cable. So I thought to myself, I think if I do the same thing that I do in the antenna, which is putting a fork, a knife in the antenna, if I do it in the cable, maybe I'll get TV cable.
Yeah.
And so the only cable I knew was the power cable in the TV. So I kindly like just lifted it a bit that the TV was still on, and I touched it with the knife. And I don't know how a huge spark came up and everything went off, and the phone was like, what? And that was my experience. I never got TV cable to work that way. So I learned something. Yeah.
I don't know. And that's how you got super.
Yes, exactly.
That's your origin story.
Like this, and electricity comes out.
I can watch TV in my mind. That is such a scientist move, and I love that.
Thank you. See how we're talking how Brandon's so kind. You can say the stupidest thing and he'll be like, say something kind. Thank you very much. That's definitely a scientist's mind.
It's a great example of reinforcement learning too, because you had the positive reinforcement of like, oh, this works, and then you're like, but this extension of that idea does not.
So I fine tuned my model a little bit. Yeah.
And that is a beautiful aspect of models, where you can get a single data point and make a substantive update.
Right.
So one thing where coming back, one thing where like gradient descent does not get us that.
It's true.
Back propagation, differentiable models, like they're great when we have a ton of data that all kind of points us in the right direction, and we can make tiny incremental changes. But to have like the one thing where it's like, never do that again, they're not really set to do that.
I feel like the way
there's a relevant question in the chat. Oh, go ahead.
Yes.
Go ahead. From Josh Bank about world models.
Yeah.
So this is like something where there's a kind of a hobby approach where I actually like try to say, well, what would that look like? It's I call it a cartographer or naive cartographer, for lack of a better word, but it's like, how do I learn, not just like how do I get to my reward, but what is the consequence of like being in state A and taking an action and ending up in state B? Like how does that tend to go? And that becomes the world model, so that when I get a new goal that requires me to traverse several states, I have a map of that world that lets me do that. So I'm very bullish world models, and feel like they're a good way to go. And very bullish on something that you mentioned a second ago about what if we had a whole bunch of very, very similar physical instantiations gathering data, like say all the same model of cars that were out there, playing bumper cars and learning how to drive, because they have the same sensors, because they have the same actuators, they could then all contribute to the same model. It's a good way to parallelize reinforcement learning.
Okay, goes back to the question.
Cool.
Yeah. I want to circle back a bit. So you said basically gradient descent doesn't take you there. You need some kind of random restart or something as a learning process, right? Also as a career process, right? We've had, I think the three of us, you've had a lot of like sort of random restarts that take you different places, or in machine learning. I just want to elaborate more on that, whether it's in machine learning or in career. Like, what do you think is a good technique to get out of the comfort that gradient descent takes you, and find different places? I don't know. That's kind of a very open-ended question.
Yeah. No, it's a really good one. To be honest, I've had help. Like, the world has has dislodged me from my gradient descent several times. But yeah, I think for me, my takeaway is that I picture the world as like this, like two-dimensional, three-dimensional landscape. There's hills and there's valleys, and maybe I want to climb that mountain, and so I start making my way that way. But it doesn't stay put. Like, what was a mountain can get knocked down and become a valley, and vice versa. Like, it shifts around over time. And so part of the world model is trying to make rough guesses about how it's going to shift and when. Or I'm on this hill and then all of a sudden it craters and then I got nothing. Like, where do I go from here? And honestly, I don't think my experience generalizes very well, because the dynamics change so fast, decade to decade, that the only thing I have is like, don't spend too much time being like, well, dang, I really wanted to be on this hill. It's like, great, be sad for a minute. That hill doesn't exist anymore. You got to choose something else. Like, you got to, whatever you do is not this. You don't have to go home now, but you can't stay. And
that's interesting. I never saw it like that, but I think I'll start. The world is like an ever-changing landscape, right? So I also have a hard time giving career advice that doesn't sound like what worked for me. But I think it's still worthwhile. Like, I think that, because I see a lot of questions that are career advice oriented. So what would you say to like a young aspiring data scientist?
I have kids who are recent graduates in mechanical engineering and computer science. So this is like relevant. And I'm like, the best I have is like, I'm cheering for you. Like, good luck. No one's going to hand you anything. The traditional method of, you look online, you see a posting, you submit a resume, you get an interview, you get hired, it's become like very broken. So don't assume, try it, but don't assume that that's going to work for you. And just talk to people who have jobs, talk to people who are looking for jobs, talk to people who are hiring, reach out, be willing to like get hired for a title that you didn't want, or a job that you didn't want, or even an industry you're not that excited about. Have your like bright lines where it's like, I will never work for an employer that does X because I would hate myself. Like, we all have to figure out where that is for us. But just don't assume that there is a path there. Like, it's wilderness. You're going to have to make your own way. And I wish that it weren't that way. And I wish I had more direction, but it's, but if you can like get to where it's like, okay, I don't assume there's going to be a grown-up that's going to come and take my hand and get me there. This is on me. Like, well, okay, what do I do about it? That's, even if you bumble around, you're winning at that point. Like, you're on the way.
That's great advice.
So
and it seems like an LLM style. Like, you can figure out the next word. And then once you get to the next word, you figure out the next word from there. And it's like one step at a time. I feel like when I stopped planning and I just decided I'm going to pick my next step as best as possible, that's as much control. I feel like the previous generation told us a lot to like, plan your stuff, and that's what worked for them. I don't think that works for ours. And I wonder if we're giving advice to the next generation
Yeah.
that's why I'm like wary. I'm like, maybe I give them what worked for me,
I'm
and they
so afraid of
go
that.
from whatever. But I think that advice is like sort of general enough that it's like, make your own way in whatever it is that the ever changing landscape got when you arrived, which is what we did, right?
Yeah.
So, one of your essays on your blog that I love is called "Being a Staff Data Scientist in 2026." I love it for a lot of reasons, because it's also gives it's career advice, which people are always asking me for, and I'm just going to redirect them to that. But one thing I think is fascinating about it is a lot of that essay talks about the disconnect between your role as data scientist and communicating to your boss and your boss's boss and your boss's boss about how to make decisions, right? As a data scientist, you are someone who works in distributions, and they are yes, no. And you somehow bridge, as a data scientist, you bridge that gap between sort of variance and, what's our best guess, to what's the final decision going to be. Can you talk a little bit about that? Do you have any examples from your career where things worked out very well, or maybe didn't, or I don't know? Do you have anything to talk about that?
And a small clarification: staff data scientist, for those who haven't worked in a big company, it's like a almost black belt, right? Like you go from data science senior, da 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 da. So staff is pretty up there. So it's a high level position, right? Yeah. Anyway.
Yeah, typically somewhere in the 5 to 8 years of
Yeah.
experience.
So anyway,
so it's like not your first
I'll
rodeo.
let you answer the question.
Yes. And at that level, like one of the themes of that was that it's more about the people that you are working with than about the skills. You need to have the skills, but then it becomes more important. Like, well, how do you tell your boss when they ask, like, well, is this going to work or is it not? Or we tried this thing, did it get better or didn't it? And it's like, well, I mean, we show that on average it got 2% better, but the error bars on that are huge, so we don't really know. But they have to make a decision. Like, they're not just being difficult. They have to say, like, so do we turn it off or do we keep this thing? What do we want to do? And that's where you have to translate this smear of information to a concrete yes no decision. And yeah, that's hard, because knowing how to do that totally depends literally on the personalities of the people involved, what they care about, what the goals of the company are, and then taking a hard look at like what the costs are of being wrong either way, a false positive or a false negative, and what the benefit is to being right. And all of that boils into, gets thrown into a big pot called judgment. And you get you make this good decisions by having good judgment, and then you get good judgment by making bad decisions. So it's like I don't know of a graceful way to do that.
Going on. There's like an equation of something, and then the contrary of that variable or something.
Yeah. So there's something about like being okay making a bad decision, like doing your best, but just knowing that you're going to fail sometimes, and that is the process. That's what gets you there. But yeah, it's messy, and that's why staff plus data scientist is like who they are, is because they are like either willing or able, or at least not rejecting the idea of taking on that role and trying to bridge that gap and deal with that level of chaos.
But there's also sort of like some soft skills involved there as well, and like you were saying, it's knowing the personalities of the stakeholders, the decision makers, and being able to not just do the math, but also sort of read the room and understand how to talk to these people. It's interesting. It's something that, like, at least for me, that's something that's never been taught, right? I was taught how to do the math. I was taught how to solve the problem in math class, but I was never taught sort of the communication skills required to give people the news one way or the other. It's interesting that, like, And that, I think, is almost the most important part. It's not, maybe not the most important, but it's a big part. Like what you're saying, it's, you have to know who you're talking to. You can't just be like, I did the math, this is the decision, bam, done. It's much more
Yeah.
gray than that. Yeah.
Yeah, Avital in the comments says company culture is so important after a certain point in your life, and that is it on the nose. Like having a boss where, if you're in a company where it's like you are not allowed to contradict the boss. I've been in those, and they're horrible. Your boss says something manifestly false, and you just nod and then find a way to like do the right thing on the side and pretend it was their idea all the time. So
Yeah.
I do not stay long at those companies. But also like when you have to correct someone, like the art of like, I see where you're going with that, and you're, here's things that are correct. Here's a part that's not quite correct, as opposed to just like, no, that's not
Yeah.
going to work.
It's like, yeah,
those get received differently.
it's like training a model. People who can't get corrected is like a model that stops getting updated with errors. So like maybe they did something well once, and then you just stop training the weights. And a lot of bosses are like that. You see a lot of that in tech. The person who did one thing right, and then later you can't contradict them because every crazy idea sounds as good as the one that worked out of chance. So yeah. But I like that your approach to learning and to ML and to leading it's similar, right? Like learn from mistakes and iterate. Yeah.
Learn from mistakes.
Yeah.
That's right.
Yeah. I want to say hi to Alessandro. He's here. I don't know if you know Alessandro Roman, is a friend of ours who was in this podcast too.
And he's got his own.
Oh, it's amazing.
He's got his own podcast. I think it's My Data Guest.
You should have Brandon in the podcast. That'd be awesome. In the Data Guest. Yeah. What else? Question. There's one that is asking if we have ADHD, and I'm like, I do. I have all of it.
Yeah.
I think if 2 out of 3 stuck a fork in the plug in the electricity, there's a high chance.
I don't necessarily ADHD, but definitely like autism. Like, special interest, dive in.
Yeah.
You can't pull it out of my cold hands. Like
yeah. I find that my difficulty for paying attention makes me a teacher, because I'm like, I know exactly how to get lost. So like the fact that I get unfocused means I have to make material that people like that I would actually focus.
Yeah.
So yeah.
Empathy
is the most
priceless.
important. If I know how the slowest person in the room feels, because it's normally me. So you just cater to that one.
I'll second that.
And if you need to dress it up, you can say building a mental model of the other agents in your environment.
Love that. That's like whoever named this support vector machines. Like it's good naming skills.
Exactly.
Love it. I wanted to ask you, AI and education, like when you, because you do a lot for educating people in AI, but the other way around, like what do you think of AI helping us learn? Or whether it's helping in education in one way or another, or even just an LLM helping us learn. Like, what are your thoughts on AI helping us learn?
I have conflicting thoughts. My experience with learning is that the learning happens when I am confused and like almost humiliated because I can't get the thing, and frustrated, like almost to the point of tears. Like it's not fun. I don't like recommend it as a leisure time. It takes a lot of energy, but that's when things really shift in my head. That's when those new categories get created, those new connections get made. I sleep on it, and like 3 o'clock in the morning, I'm like, oh, I see it now. Like, let me go code that up and make sure that works. But it totally clicks. If I have a window where I can say, hey, explain to me how blah, blah, blah works, and I get a very plausible response back, I don't get a lot out of that. I could learn to memorize those words. I don't know if they're correct. They might be most of the time, but if they're not all the time correct, that's a shaky foundation. And so I'm like, ooh, that's if we're building that into the core of our AI education process, it makes me very nervous. That said, I use AI all the time at work. I love to have it check my work because it catches all the things that I don't see, all the bugs that I introduce. I love to catch it when it's wrong, because then it like just makes me feel good. But also like it's so good at retrieving things and like putting things together. And even if it's like 80% correct, like there are jobs that it can do really well. So there is a really useful place for it.
Yeah. Any chance
Cool.
you're going to turn some of your book projects into books?
So if you go to my blog, it says book project. There's chapter numbers and everything. I went through the arc of like, I'm doing academic publishing. Wait, I'm not in academia. Why do I have to submit myself to getting papers reviewed? I'm going to like write a book. I did actually start publishing chapters of a book. And I started saying like, wait, like why am I doing this? Like, I'm not going to like make my living selling paper books. I'm not that kind of an author. I don't write stuff that's going to sell a million copies. So what would I do if I were doing it just for me? And the answer is this format. I've just decided to call a book project, where it's a loosely grouped sequential set of posts. Some of them, though, are posts, some are videos, some are actually software libraries, some are like little demos or apps, and they just represent my progression of my thinking on a particular topic. So short answer is no, I don't have any intention to turn those. I love paper books. Our house is covered with paper books, but that's probably not the direction I would go.
Well, if it ever changes, I'll be the first one to get it.
Exactly.
Thank you.
Yeah.
Thank you.
Cool.
Very cool.
We have a rapid fire section.
Yes.
Okay.
That we've started recently, and it basically we mimic Josh's great characters, Squatch and Norm. One's a dumb one, one's a smart one, from what I've picked up. And I'll be Squatch, which is the dumb one. Is that Norm?
This is Norm, but it has spikes.
It's not the same species though. It's
it's got spikes, but it's close. Yeah.
So I'll ask the Squatch once on Squatch voice, and Norm will on my best impression of Squatch voice, and then Josh will do his perfect impression of Norm because he created the Norm voice.
Yeah.
Okay, rapid fire. Who's your favorite robots in movies and your least favorite?
Favorite is Wall-E.
Oh,
he's like the perfect robot. He does a useful job and he just does it over and over again, and he grows, he learns. He's classic. Least favorite, there was a movie called The Black Hole, and there was this big terrifying looking robot called Maximilian, who literally had spinning lawnmower blades pop out of his shoulders, and he was just like this quintessential villain, but he was dumb and clunky, and he just gave robots a bad name. So he's at the bottom of the list.
What is your favorite aspect of robotics?
The like real answer, or the public answer, is like I love building something that can do a job really reliably for me, and I don't even have to think about it. But the real answer is like I love watching a thing that just like behaves. It just does stuff that I didn't explicitly tell it to do. That's magical.
Yeah.
Favorite and least favorite Star Wars movie?
I know I'm going to make a lot of people mad probably. So my favorite is Rogue One. That's just like, to me, that's like the best of Star Wars, bubbled up into one. Even as growing up on the OGs. Least favorite is anything with a whiny grown-up Anakin. Like, cannot stand it. Worse than Jar Jar Binks. Like he just nails on a chalkboard.
Yes.
What's your favorite LLM?
My very favorites are the ones that I've seen that are like variants that are small, that people have like made in their own little space, like SMLL, small LLMs. But I do have to say my daily driver at work is Opus 5. Been solid, no complaints. So nice. Yeah, that's my
window or aisle.
Window. Just make a little cave. I'm guaranteed one armrest. that's my safe place.
You're in a cave and you get
aisle's great
information. You're curious. Yeah.
That's right.
I'm the window.
Aisle's great for getting to the bathroom, but The Windows still wins for me.
I've been noticing that, like, I've got one more Norm question, but just to talk about the window versus the aisle, I've been noticing that, like, now that everyone watches movies on planes, no matter how short or whatever, nobody opens the windows at all. You're just in a dark tube for regardless of the length of the flight. And I was like, the window seat has power. You can open that thing up and look
There is
out,
a lot of
and you
power.
can close it. But if you're not sitting at that window seat, you're literally in the back seat. You're just waiting for someone else to either open it or close it, and it's up to them. All right.
That is
powerful.
actually a good point. I hadn't thought about that.
One more from Norm. Norm says, favorite go-to algorithm? ML. Do you have a favorite ML? Morgan?
I'm going to go classic gradient boosted decision trees.
Oh, I kind of guessed you were gonna go there. Yeah, so the XG boost direction. I was like,
And that's
Now wait a minute.
I've never done a video on.
Wait a
them either,
minute.
but they are
Gradient
awesome.
boost. You're not going to go like, you're not going extreme. You're just
XG
going
boost?
like, you're just going gradient. You're not like
I don't need to get crazy.
so just gradient boosting. Okay.
just gradient boosting.
You,
And
you
not-
showed restraint.
Not picking like XG boost or cat boost flavors. Like it's we're all friends. It's all good.
Dang.
But no, gradient boosted decision trees are just like the balance of like the most you can do with the least amount of data, the most flexibility, and some amount of explainability in there. It's just like a sweet spot trading everything
Right.
off.
Nice.
Well, Brandon,
Thank
I
you,
gotta
Mr. Roar. Sorry, I wanted to say your
Exactly.
last name in Squatch voice because it's just Roar.
Yeah. Thank you, Brandon Rohrer. Thank you very much. This is wonderful. It's been a real pleasure having you on the Triple Bam with Josh and Lewis podcast live stream.
It's been such a delight. Thank you so much for having me.
Thank you. As I said, we're huge fans. Thank you for all you've done for us and also for the space of AI, for the space of education. And everything. So it's been wonderful to have you here. I wanted to just have this great conversation, and the fact that we had people watching, asking great questions. Thank you for the people who asked the questions too. So yeah.
Right.
Thank you.
Yep.
Thank you all.